Hi everyone, I'm the plant propagator and welcome to my channel. Today I am in the laboratory in Southwest Florida, and what I want to do is talk to you today about phototropism. So this happened, and I'm talking to you about phototropism because I went to the Midwest USA for about 3 weeks. I gave an orchid talk. I give a lot of orchid talks in my local community in Southwest Florida. I actually gave one in St. Louis this past week. But anyway, mostly in Southwest Florida, I give orchid talks. And I wasn't coming back to the lab. What I do when I give my orchid talks is I bring flasks in like this, or I bring plates, or I bring plants in to show people what the seedlings look like. The last talk that I gave in Southwest Florida, I brought this flask and a few other ones and a few petri dishes in, and then I didn't have an opportunity to come back to the laboratory here, so I just put them at home in a bright window, not a sunny window, a bright window, for about 3 weeks. When I came back, I saw that orchids are phototropic, and they respond to light. It's not surprising. They respond to light in certain ways. And what I wanted to do today was just explain to you what phototropism is and tell you a little bit of the biology behind it. First of all, what is it? So phototropism, photo is light, and tropism is response or movement. And what phototropism means is that when the plants respond to light by growing towards the light. And what I have, and you can't see it real well in this flask, but what I have is the plants. The light is coming from this direction, and the plants bent in that direction towards the light. And this is not surprising, and you've seen it all before, and even if you grow orchids or any plants, that they will grow towards the light. Okay, what is going on? Well, yeah, they bend towards the light. It's better for them to be towards the brighter light. But there's a really interesting background and information behind it. So first of all, it's called phototropism. Plants have pigments that allow them to respond to certain lights, and the pigments that we're most familiar with are the chlorophyll and the anthocyanins, which give it anywhere from the red to the purple pigmentation. The pigments in the plant that allow it to respond to light, the phototropic pigments, are called phototropins. And these are, it's interesting because they respond to blue light. So if you shine blue light on from this side to the plants, they'll bend towards the light. If you use other wavelengths of light, depending on what it is, they won't bend towards the light. What happens in these plants is they have, again, these blue light absorbing pigments that direct the plant to light. But what happens in the plant is that you get accumulation of certain hormones, and the hormone that accumulates is indole acetic acid, or IAA, which is the auxin class of hormones. And what happens is, as the plant is growing this way, the auxins will accumulate on this side of the plant, and you'll get cell elongation on cells on this side of the plant. And what happens when you get elongation of these cells, the plants will bend towards the light. It's a really simple physiological response. It's been known for many, many years. For a few years, what people thought is that the light was shiny because there's a lot of growth regulators that are sensitive to light. So for a few years, it was thought that the certain growth regulators on this side of the plant that are receiving the light would be degraded by the light, and that would cause this curvature. And the reality of it is that doesn't happen. And there's some experiments that were done in the very early days with certain monocot, coleoptile, certain parts of the plants, and it was shown pretty clearly that it wasn't due to breakdown of these auxins on this side of the plant, but it was a result of accumulation and production of auxins on this side of the plant. So what happens again? during phototropism, which is a blue light response, is that the phototropins, the pigments, perceive the light and they cause auxin or accumulation on the side of the plant that makes it bend towards the light. All right, so that's what happens in the case of this dendrobium. And I'm sorry, you can't see it as much anymore because I brought it back to the lab, it's been sitting here, but you know in a general sense what I'm talking about. So that's all I have today. I just wanted to give you a quick explanation of phototropism in plants. This happens to be, I'm bringing it to you because it was real pronounced in my orchids as they were bending towards the light. So that's all I wanted to share with you today. The other thing is I just wanted to really briefly tell you that this flask, I'm sad, this flask has some, and it's one of my oopsies, it has contamination in there. I don't know if it's because I've been dragging this around to shows, but there's some contamination in there. So what I have to do is actually pull these, and these are dendrobiums. So and it's a new cross that I made. I'm going to have to pull these dendrobiums. I'm going to have to deflask these dendrobiums. And what I'm planning on doing with these dens is making my first burlap dens. I shared with you burlap valves and how well that's working. Now I'm going to move on a little bit. I've heard somebody commented that they want to try it with the cattleyas, and I'm sure it'll work fine for that. But I'm going to try it with the dens because that's another orchid that I really like to mount onto trees. Anyway. Back to this stuff. That's all I have for today. I wanted to talk to you about phototropism and tell you what I'm doing with this flask. I hope you enjoyed my video today. If you did and you'd like to see the videos coming, it would help me out if you could click on like, share, and subscribe to my channel if you're not already a subscriber. Okay, that's all I have for today. I hope you enjoyed it, and happy propagating.